All right, so in this problem, they're going to give us 4 feet of wire total, okay? And it's going to be used to form a square and a circle, okay? So two things. I guess you could say square and or a circle, because maybe all of it being used to a circle would be best. Maybe all of it being used on a square would be best. Or maybe a little bit on the square and a lot more on the circle, or maybe more on the square but a little bit on the circle, right? There are situations that could arise where you could use both shapes or one or the other. Okay, so we're going to use this to form those two shapes. It says how much of the wire should be used for the square and circle, and like I said, and or circle, I guess, to enclose the total maximum area. So what am I going to optimize? What is it that I'm taking a derivative of? Area, right? Because they said maximize area. Okay, so so I'm going to maximize that. This thing, oh, sorry, it was frozen. So yeah, I'm going to maximize that. So I'm going to kind of think about my situation here. I'm going to have a square and I'm going to have a circle. Okay, so I have a square. See if I can draw a decent circle. All right. So I have a square and a circle. What formulas can I use? Huh? So I can use area formulas, right? Obviously, I need area formulas. So let me put that down. So if I'm going to use one and or the other, let's put a formula where they're both put together, right? Because I'd like to optimize them both at the same time. So I'm going to just basically call it area total, okay? A sub t. Okay? So you said that the area is going to be pi r squared for the circle, and for the square, what do we put? All right, so x squared plus pi r squared. Can I take a derivative of that the way it is right now? How many variables? 3. Can I take a derivative? No. I mean, I guess I could, but not to help me do what I want. If this was related rates, sure, in some cases it might be okay. But in optimization, usually it's not. So that means we need a secondary equation, right? Think about this. What's a secondary equation? So I'll give you a minute so maybe you guys can think about what would be another equation you could use. All right, so anybody have an idea? Secondary equation that we can use? No? Well, we are told that we can use a maximum of 4 feet of wire, right? And I have to create these shapes. When I create these shapes, I create outlines of these shapes, right? What is that? An outline of a shape? Perimeter. Perimeter. Yeah. It's perimeter, right? So I can put perimeter total. What's the perimeter of a square? 4x. What's the perimeter of a circle? No idea. You know, you just don't call it that. Circumference, right? Why they changed the name is kind of weird, but yeah, 2 pi r. Do I want to take a derivative of perimeter? No, because that's not what I'm maximizing, right? But I could solve for a letter, right, and then plug it into the area formula. That way I can get 2 variables, right? What's my perimeter? 4. That's the total. I can't have any more. I want to use all of it. I don't want to say I'm only going to use half and I'm going to maximize my area. That's not possible. You want to use it all, right? So 4 is equal to 4x plus 2 pi r. And what I'm going to do is I'm going to solve for, basically anything I want to, x or r. It's up to you. I don't know. I'll just solve for r since we prefer using x's and y's, right? So let's solve for r. So 4 minus 4x is equal to 2 pi r. We'll divide by 2 pi, sorry. So that tells me that r is equal to 2 minus 2x over pi. Notice I reduced, okay? Let me move this up. I did reduce the 2. So now I'm going to plug that into my area formula. So a sub t is equal to x squared plus pi times 2 minus 2x over pi squared. Let me mess around with this a little bit. I'm going to factor out a 2 from this thing, okay, from just out of the parenthesis. I'm also going to factor out the pi. But since they're inside of a square term, I got to really factor out a 2 squared and a pi squared, okay? So it's going to look like this. A sub t equals to x squared plus 2 squared pi over pi squared 1 minus x squared. I took out the pi from the bottom of the fraction, but since there's 2 of them, right, because it's squared, I got to take 2 of them out. I factored out a 2 from the 2 minus 2x, so that basically allows me to bring it out, but it's a 2 squared, right? So if I simplify, I get a sub t equal to x squared plus 4 over pi. And then inside of that, if I expand it, it'll be 1 minus 2x plus x squared. Let me just any questions so far? I know the math looks really weird, but it's not that terrible. It's a lot easier than it looks, okay? It might look a little weird right now, but it's a lot easier than it looks. So now what I'm going to do is I want to optimize this thing, okay? But I want you guys to think about this. Remember how we talk about feasible domain, right? How big can x be, right? What's the maximum x can be? And before you say it, think about it a little bit more, because most people are going to say 4. But that's not right. Okay? What's the maximum that x can be? Well, let's go easy first. What's the minimum? 0. Don't use any wire, right? What's the maximum? Who said that? Why?
Because use 4 sides of the square.
There you go. You want to use all of the wire, but you can't use all 4 sides on one side of the square, right? So you want to use the maximum on one side, which would be 1, 2, 3, 4, right? So good. So yeah, our feasible domain for x is between 0 to 1, okay? So just so you understand that, because we're building our square first, okay? So now that we have that, let's take our derivative. So there you go, d a sub t over dx. Now the derivative of x squared is just 2x plus 4 over pi. That's just a constant, okay? So don't let it freak you out. The derivative of 1 minus 2x plus x squared is negative 2 plus 2x. I just took the derivative of the inside of the parenthesis. That's all. So let me distribute. We have 2x minus 8 over pi plus 8x over pi. Now I have to solve for x. Well, I got to set it equal to 0, right? So let's do that. 2x minus 8 over pi plus 8x over pi equals 0. Now I know this looks like it's going to be hard to solve. It's actually not that bad. let's move the constant first. The negative 8 over pi. So that'd be 2x plus 8x over pi equals 8 over pi. Okay, now I'm going to factor out the x from the left side so I can isolate it. So x, 2 plus 8 over pi equals 8 over pi. So my last step to get x by itself is to divide by 2 plus 8 over pi. So x, whoops, I don't know what that was, is 8 over pi divided by 2 plus 8 over pi. Now if we simplify that, this is what you get. So I'm just going to kind of go to it just so we can get to the end here. If you simplify the denominator, then multiply by the reciprocal and simplify, you'll get 4 over pi plus 4. Which you can write as a decimal if you want. I just left it as the actual value. Okay. So, I just found my critical number, right? And I got to see if this is where it's biggest, right? If my area is largest at that point. So what I'm going to do is I'm going to get my area formula. Let me go back up here. So here's my area formula. Okay, there's my area formula. And I'm going to find a of 4 over pi plus 4. Right? And then what did we say our domain was? 0 and 1. Now I'll give you the answers to this. For the first one, 4 over pi plus 4, you get 0.560. For the second one, the a of 0, you get 1.273. If you get a sub 1, you get 1. Okay. So which one maximizes my area? A of what? 0. Well, a of 1 is 1. A of 0 is 1.273, and the other one's 0.56. So which one's bigger? 0. So what does that mean? If x equals 0, and you said x was referring to the square, right? But they said x is 0. So then where do they put the wire? All in the circle. So to maximize area, just make a circle. Don't bother with the square. Okay, just make a circle. So we'll put that right here. To maximize the area, just use all the wire towards the circle. All right, so like I said, different situations. Maybe they're trying to find area within a certain range, right? Or maybe they just want to figure out like what would be an optimum value, not maybe the biggest, but what would be a place that you can make it so it's pretty large. So you could say, well, in between, right? 4 over pi over 4. But in our case, they just want us to give them the largest possible by building one or the other. This is called finding the optimal point at the end point. Okay, so it could happen at endpoints as well. All right, so we'll stop right there and I'll give you guys your homework. All right, so homework is on page 223. Numbers 4 through 7. 13 through 15. 17, 18. 21 and 22. Remember, Monday will be a book day for you guys. Tuesday, most likely as well. So far, we'll decide today. Let's see what's going on. But yeah, there's going to be a test next week.